You all can see many things are related to bioinformatics, ICT, and other. But apply at this level is more complex. Okay, I speed up my process. I would like to show that near field is the contamination near the subject. The far field is the situation of pollution, the set of pollutants or source of pollutants around the subject, and the aggregate pollution is the merging of distal and individual pollution. Okay, the personalized exposure assessment, as I synthesize it, as a many contact point with personal medicine, because it is possible to, as I said before, to monitor in real time the level of exposure of an individual. At the moment, it's only prototypes, but it's possible to evaluate to use this approach in a future. You can see I put this slide because to show how ICT, remote monitoring and other, in terms of computer science and engineer, play an important role, a central role in the future in this approach. Target analysis is absolutely related to the approach using the screening, such as or now standard techniques in molecular biology, NMR, HPLC, MS, what you want. Non-target is a qualitative information about large of component of exposome. Is the missing information. They can be qualitative data, for instance, interview, for instance, some weather condition or what you do. But this approach or at molecular level, many pollutant doesn't have any biopsy to test the toxicity. I will show an example. As an example, I am working on phthalate. On PubChem, there are about 2,000 phthalate. Only about 600 fit the Lipinski's rule of 5 in terms of toxicity. Only 33 are supported by experimental screening. And the other are in non-target approach. We must to analyze the toxicity, and the new high throughput screening can allow. Okay, large variability. This is the constraints of exposome decision making. The variability. The variability includes genetic variability, environmental variability, and so on. And sensitivity of the method that you are applying to monitor heat and to analyze it, each element of the context. The balance is between the quality of exposure and the cost of data acquisition. This is a big problem. Okay, I can monitor 2,000 compounds, but I must to buy an instrument that is $1 million. Probably nobody makes this monitoring. This point is important in terms of engineering to develop new techniques, multi-scale, that capable to monitor multiple substances, but cheap. The technologies such as smartphone and other tablet-based or other now are offering a great opportunity combined with new advanced nanotechnology methods to develop cheap system for multi-pollutants analysis. The context is integrated, what I say, you can consider an integrated monitoring system, satellite, fixed stations on the soil, on the water, what you want, and you integrate the two things. And the contamination, the problem is similar to the problem of experimental in pharmacology or other, how to collect the sample, limiting the interference of contaminant or other substances that can mask or can be a decoy in terms of selected pollutants. Okay, this is, in terms of ICT, this is the ontology of exposome. The exposome concept central, you can see the reference you can find, this is a central concept, and the other are the elements of this concept, such as exposure receptor or exposure structure, exposure outcomes. Then this suggests that in the future, one of the first steps is to develop an ontological system that can be used for machine learning, that can be used for data integration. Okay. A workflow that can be used, that can be relatively easily implemented. You have some monitoring from river, from air, what you want. You can do the targeted analysis. The characterization of the chemical is quite easy, now standard. And go to the dose hazard and dose response assessment. Non-target identification is more complex because you can have two ways, or identify the bioactive chemical inside, quindi remove the chemical that are not potentially active, new chemical, collect the toxicity data, and both of the systems go to the hazard and dose response assessment, and we expose. And the star is the decision support system to mitigate the problem. Any of these things must finish inside a machine learning box or a computer system box. Okay, this is another possible way. The chemical of interest, IEEE screening. This is a search of analogs for chemical physical. It's possible to find similar structure. Toxicity data of best analog. The POD is defined at the point of the dose response curve corresponding to the minimal effect. Over this point, there is a detrimental effect. And then after to the pharmacokinetic and bioactivity of chemical. Then come back in the pharmacokinetic system. Okay, this is the last. Is from my point of view, how it's possible to split the exposome into different submodules, but that can be connected by an ontological system or by some knowledge discovery systems. You have geological and climatological data, remote sensing, multi-omic data, what you want, socioeconomic data, census, or other information coming from central administration, local administration. Environmental data is the monitoring, essentially, are the monitoring given, are the result of monitoring systems. What are they called? Here you monitors, is engineering and physical approach. Here is the chemical approach. In this case you develop the system, in this case you acquire the data. Then merge together. Now, as you see, any of these boxes contain a lot of things. Multi-omics, that is more easy to understand. We have almost 10, 15 different fields. Environmental data, more or less, and so on. These indicate the large complexity of the problem to face. Please? Okay. This is the estimator of health. We have different points that are important. the time, the strength of oscillation of the mixture, the consistency that is equivalent to the information consistency in the database, the plausibility, that is the uncertainty of the quality of the prediction, on the reliability of the prediction, the specificity that is more similar to the specificity in machine learning, and the coherence. The coherence is they give account of the result of prediction with the experimental result. In this case, there is a problem about the degree of uncertainty in the process of the disease. Thanks. This is a list of some exposure, some reference about the exposure, are quite recent, but I guess to give you other references in the tutorial. Some points that are not clearly going to deep here, we can talk in the tutorial. Thanks a lot for your attention.
So the lecture is open for discussion. If you have any questions, you can ask him right now. So if there are no questions, let us thank Professor Patricio for
Don't worry, there is no problem. If something is not clear, we can talk.
Yeah,
outside.
he is available here all the time, and even after the session also you can ask him questions, you can contact him, and you can collaborate with him. He is the stalwart of this field now, and there are a lot of opportunities for you people. So with this I thank you. Thank you.
Only an advice. This was the more confused presentation because there are too many things. The other are more compact.